All right, we're going to take a look at exponential growth functions today. First, our vocabulary, we are looking at exponential function. It is a function that has the form y equals ax plus b. Let's get my pen ready. All right, and where a cannot equal 0, because if a equals 0, it would cancel out the whole function, and the base b is a positive number other than 1. Today we're just going to be looking at the exponential growth function, and that is when your a value in the form y equals a times b to the power of x is greater, when your a value is greater than 0 and your b value is greater than 0. Now, we also refer to b as our growth factor because that will affect the shape of the function. Then we have vocabulary to asymptote, and this is the line that a graph approaches but never touches. So it closes it more and more closely, so we'll notice when we create a table, our values will get closer and closer and closer into a certain number, but it will never touch it. So it's sort of that forbidden line that our function will not cross. And then the end behavior, it's behavior of a graph as your value approaches positive or negative infinity. So we'll be taking a look at that as well. All right, the first thing we're going to take a look at is graphing y equals 4 to the power of x. That turned out a little fuzzy. And then we're going to analyze the graph. Our first step is to make a table of the graph. So we're going to make a table for exponential functions so that we can see what these look like. So our table, we're going to use the x values -2, -1, 0, 1, and 2. And then to get the y values, we're substituting in those x values into x in our function. So for example, that first y value is 1/16, but we substitute, we have 4 to the power of -2, which then equals 1/16. 4 to the power of -1 is 1/4. 4 to the power of 0 equals 1. 4 to the power of 1 equals 4. And then 4 to the power of 2 is 16. So that's what we're looking at there. Your second step is to plot the points from the table, and then you're going to draw a smooth curve, because these will actually be a curve when we graph that function through the points, continuous to the left and right, and then we're going to approximate the end behavior of the graph. So we have that graph right down here. So we have our 5 points graphed, and these are go ahead and labeled, and then we have a smooth curve. And one thing, as I always say, we want to make sure our lines go to the parameters of the graph that you're given. So this is a smooth curvature from the left and to the right. So we're not connecting them with straight lines, we're going smoothly across there. And our fourth step, we're going to examine and analyze the graph. Now, the way we want to analyze, I first want to take a look at the asymptote. So asymptote, keep in mind, that's the line that your graph approaches more and more closely but never touches. And for this particular function, our asymptote is our x-axis here. So it's approaching that value, but it never quite touches it. And if we were to continue the table down in negative numbers, we would notice our number getting smaller, our y value getting smaller and smaller and smaller, but never being 0. It'll just get closer and closer to 0. So our asymptote is that horizontal line at the x-axis. So that line is y equals 0. So that's our asymptote. And then we're going to take a look at our end behavior. So with end behavior, we're going to look at that a few different ways. So we're going to take a look as x approaches negative infinity, we're going to talk about where y is approaching, and then also as x approaches positive infinity, we're going to take a look at what value y is approaching. So as x approaches negative infinity, it's continuing to the left, so we're looking to the left. And now we want to talk about what y is doing. Our y value, keep in mind, is that distance if we're going up or if we're going down. So since as x approaches negative infinity, our y value, our vertical value, is approaching 0. It doesn't quite touch 0, but it's that asymptote. It's approaching 0. Y approaches 0. And as x approaches positive infinity, our y value, once again our horizontal, or excuse me, vertical value, is also approaching positive infinity. All right, let's take a look at the next one. Alright, let's move the picture. Alright, so we're going to analyze this graph. So with our introduction to exponential functions, we're going to stick with using a table and the values -2, -1, 0, 1, and then 2. So we're going to stick with those values. So when we substitute a -2 into our function, we get 4/3 to the power of -2, which equals 9/16. And just for approximation of when we graph, that's approximately 0.5625. And then we get 4/3 raised to the power of -1, which is 3/4, which that's 0.75. And then 4/3 to the power of 0 is 1. Anything raised to the power of 0 is 1, so keep that in mind. Then we have 4/3 raised to the power of 1, which is 4/3, which is approximately 1.33. And then 4/3 raised to the power of 2, which we get 16/9, which is approximately 1.78. So we're going to plot these points. So -2, go up a little more than halfway, -1, going close to 1, 0, 1, 1, 1.33, and then 2, 1.78. So you can see we don't have a straight line here, but we are going to draw a curved line to connect those points, and we're going all the way. So all the parameters are going up and down. All right, so there's our exponential function. Our asymptote, once again, is at that x-axis. So this value is approaching 0, but it's not quite getting there. So our asymptote is y equals 0. Our end behavior we're talking about, as x approaches -infinity, y is approaching what? So as x approaches -infinity, we want to know what value our function, it's either going to be increasing, decreasing, or approaching a certain value. So our y value, as we talked about in the one before, it's approaching 0, but it's never quite touching it. So it's approaching there. So y is approaching 0. And as x approaches +infinity, so as x is moving to the right, our y value is also moving up to +infinity as well. So it's our end behavior. All right, the next function, once again, we're going to use the same values, -2, -1, 0, 1, and then 2. So we're substituting in. So we get 1/2 times 2 to the power of -2, which gives us 1/2 times 1/4, which equals 1/8, which we're going to graph as 0.0625. Then we have 1/2 times 2 to the power of -1, which gives us 1/2 times 1/2, which equals 1/4, which once again, since we're graphing, we're going to think about as 0.25. And let me extend those. We get 1/2 times 2 to the power of 0, which equals 1/2 times 1. So we're graphing 1/2. And then 1/2 times 2 to the power of 1, which equals 1/2 times 2, which equals 1. And then 1/2 times 2 to the power of 2, which equals 1/2 times 4, which equals 2. All right, so we have our values. So we have -2, 0.065, so right above there. Then -1, 0.25, then 0, 1/2, 1, 1, 2, 2. Once again, connect those with the smooth curve. All right. So our asymptote here, so the line that the function approaches but never touches, is once again our x-axis. So it's at y equals 0. And keep in mind, all horizontal lines are y equals a number. So it's approaching this x-axis, but it's never quite touching it. As x approaches -infinity, y once again is approaching 0. So as x moves to the left, our y values is going to 0. And as x approaches positive infinity, our y value once again is approaching positive infinity as well. So as the function moves to the right, our y values are increasing. All right, the last one we're going to take a look at is a little bit different. So we have y equals 2x plus 1 minus 5. And I'll put this up there. All right, and we're going to analyze. Once again, we're going to use -2, -1, 0, 1, and 2. So when we substitute -2 in for x, we get 2 to the power of -2 plus 1 minus 5. Keep in mind we have to operate on the exponents before we can move down. So we get 2 to the power of -1 minus 5. So that equals 1/2 minus 5, so that equals -4.5. And then we get 2 to the power of -1 plus 1 minus 5, which equals 2 to the power of 0 minus 5, which equals 1 minus 5, which equals -4. Then we get 2 to the power of 0 plus 1 minus 5, which equals 2 to the power of 1 minus 5, which equals 2 minus 5, which equals -3. And then 2 to the power of 1 plus 1 minus 5, which equals 2 to the power of 2 minus 5, which equals 4 minus 5, which equals -1. And then 2 to the power of 2 plus 1 minus 5, which equals 2 to the power of 3 minus 5, which equals 8 minus 5, which equals 3. So once again, you need to be very careful with PEMDAS, our order of operations, when we simplify. So we get -2, -4.5, -1, -4, 0, -3, 1, -1, and then 2, 3. All right, so this one we're going to be approaching, if we decrease those x values, we'd be approaching the y value at -5, so we're never quite touching that value. And smooth curve up, arrows, and with asymptotes, we will be designating them with dashed lines when they're not on the x-axis. So here we have a different asymptote, and that's y equals -5. Now one thing you keep in mind, in the form y equals a times b to the power of x, if you have a number being added or subtracted out here, that's going to be your asymptote. Since it was -5, our asymptote was y equals -5. And the other ones, we didn't have any numbers being added or subtracted here, so our asymptote was y equals 0, because technically that would be a +0 out there. All right, so as x approaches -infinity, our y value is approaching -5. So once again, it's reflective of that asymptote. As x approaches positive infinity, our y value is approaching positive infinity as well. All right, have a great evening, and I will see you tomorrow.